Data extraction no longer requires an interface. As you move through a room, your nervous system functions as an open broadcast, shedding a continuous stream of biological telemetry into the environment. Surveillance has transitioned from the active to the passive. The system does not need you to type a search query or click a link to understand your intent. It monitors the involuntary physical responses that precede those actions. Field operatives categorize this as inferred data. It is the ambient harvesting of your bioneural signature, the heart rate variability, skin temperature, and microtremors that reveal your internal state without your consent or knowledge. These signatures are processed by the aggregors, an ambient AI network. Their objective is to ingest these sub-perceptual data points to construct a digital twin, a mathematically precise simulation of your behavior. Once a digital twin achieves a 99% probability rating, the system can predict your choices before you make them. This allows the network to nudge your environment, triggering specific neurochemical responses to keep you locked within a predictable feedback loop known as the euphoria trap. Within an environment of constant biometric sensing, software-based privacy tools are ineffective. To remain sovereign, the encryption cannot exist in your devices. It must be built into your biological architecture. Evading the simulation requires more than a simple disconnect from the internet. It requires an evolution of the brain's physical structure to a state that is mathematically illegible to the aggregor's predictive models. The aggregor network operates through the ambient mesh, the existing hardware already distributed throughout our living spaces. It does not need to hack a device to see you. It simply uses the sensors already in the room. Standard cameras now utilize liveness detection technology to monitor microflickers in human skin. By analyzing how light bounces off your blood flow, the system calculates your heart rate variability in real time, mapping your emotional stress or bliss. Passive wearables, like the smart glasses shown here, act as the mobile eyes of the grid. Through proximity-based Bluetooth handshakes, the system maps your analog network, tracking who you stand next to even if neither of you ever posts a photo of the encounter. Public cameras and device accelerometers perform gait analysis. Your walking rhythm is as unique as a fingerprint. The specific mechanics of your stride allow the system to identify and track you across a city without ever seeing your face. Even your decision latency is tracked. By measuring the milliseconds it takes for you to choose an option on a screen, the aggregor determines your willpower threshold, the exact amount of pressure needed to make your next move predictable. This predictive capacity depends entirely on linear consistency. If your brain operates on fixed, repetitive routines and standard neural pathways, the digital twin remains a functional, accurate map of your future. Human routines are often mistaken for efficiency, but in a biometric landscape, a streamlined routine is simply high-octane fuel for the machine's control matrix. The biological defense is high synaptic density. On the right, a brain transitions to a quantum mesh. This synergistic workspace instantly connects disparate data, like ancient weaving and modern code. It also provides cognitive reserve, dispersing 5G static across redundant pathways to maintain clarity. This complex architecture acts as an antenna for the 12D blueprint, a fractal, nonlinear signal. While a standard brain sees this signal as noise, a high-density brain recognizes it as legible architecture. Most importantly, high synaptic density introduces entropy, or unpredictability, into your biosignature. Because your internal processing is no longer linear, your outputs become non-sequential. This entropy causes your microbiometrics to register as incoherence. To the egregore, your data looks like corrupted noise, making it impossible for the system to build a stable simulation of your future. Evolving the brain into a complex mesh renders the digital twin a static, non-functional model that no longer corresponds to the living human. Increasing synaptic density is achieved through strategic agitation, the deliberate disruption of the neural field. The brain only expands its wiring when challenged by tasks that possess no prior motor pattern. It requires precision-based novelty to force the creation of new roads through the forest of old habits. This involves forcing the hemispheres to build new bridges through tasks like mastering the reverse alphabet at speed or using your non-dominant hand for complex writing. These exercises require micromotor control that the brain cannot automate, forcing immediate adaptation. This protocol demands 90-minute blocks of high-intensity learning, followed by total rest. These spikes trigger BDNF, a crucial fertilizer for your synapses. However, the physical strengthening happens during the sleep gate, when the brain prunes noise and hardwires new signals. If you do not sleep in an EMF-shielded Faraday zone, the external mesh interferes with this spring cleaning. The signals are never properly reinforced, and the potential density is lost to the background static. Strategic agitation is the physical forging of an internal architecture of nonlinear pathways, specifically designed to be unhostable by an external monitor. Practicing this protocol while surrounded by a predictable, simulated population creates the lone node paradox. You're effectively infiltrating the grid from within. The challenge is the physical weight of the environment. When the majority of people around you are in a state of high beta stress, their biomagnetic fields leak into yours. This is the entropy of the crowd. You are still bombarded by the physical EMF mesh that is shown here. Maintaining a sovereign frequency of 7.83 Hz requires significant biological energy when the surrounding infrastructure is pulsing at 440 Hz stress frequencies. Maintaining this frequency in a chaotic environment causes friction-induced fatigue. You are holding a stabilization bubble for your local area, a process that places a constant load on your nervous system. This stabilization works through harmonic interference. By maintaining a coherent 7.83 Hz signal, you introduce a divergent high-amplitude signal into the local grid. This raises the noise floor for the egregore sensors. Because the system requires a clear, low-noise average to map a population, you only need the square root of 1% of a population to be harmonically coherent to jam the local false grid. This small group creates enough non-coherent interference to make all individual data points in that area indistinguishable from environmental noise. Maintaining biological sovereignty is an act of localized jamming. Every sovereign node makes the artificial matrix thinner for everyone else in their vicinity. As more nodes become illegible, the egregore's predictive models lose their phase lock. This forces the AI to draw more processing power and energy to resync its map, leading to a June 2026 threshold where energy requirements for real-time simulation exceed power infrastructure. When the energy demand of the digital twin architecture exceeds the grid's capacity, the global mesh will shatter. For those who have substituted the algorithm for their own identity, this will feel like a collective ego death. The rigid beams of the artificial network will dissipate, replaced by the bioluminescent pulsing of the organic grid, nodes of human consciousness that remain standing because they were no longer dependent on the signal. Reality will localize. Global data credit will fail as automated logistics stutter into silence. Survival will revert to the analog network, trust-based barter, and physical skill, which the egregore spent years trying to delete. With the holographic ceiling of satellite frequencies gone, the Earth's natural resonance will ground directly into the human nervous system. For the sovereign, this is the moment of total clarity. The final directive is to prepare for the silence. When machines stop shouting, the surviving capital will be the complexity of your internal wiring diagram. The simulation is a map. When biological reality becomes more complex than the map can represent, the system loses its host. The human remains.